Hello my dear students, welcome to Power Electronics GATE and ESC classes, continuation of Power Electronics concepts. Students, in this session, I would like to discuss about how to calculate conduction losses in a semiconductor devices. Students, this is also very important concept mainly for GATE and ESC point of view. This is one of the fundamental topic in Power Electronics. Based on this topic, already questions are asked in GATE exam and ESC exam. Don't neglect this concept, students. Before starting how to calculate conduction losses in a given semiconductor devices, first we have to know some minimum knowledge on how to calculate average and RMS values for a given waveform, students. Here I am giving some fundamental points that you have to concentrate. You already know one of the fundamental subject, that is network theory, how to calculate average and RMS values, but my point of view I am giving some important points, students, that you have to concentrate. First I am writing for a given function how to find the average value. The average value equal to, if any function is given, the best method of calculating average and RMS values are integration method, students. That I am writing 1 by 2 pi integral 0 to 2 pi f of omega t d omega t. What is the another name for average value, students? It is also called mean value. Is correct? It is also called mean value. Then how to find RMS value? How to find RMS value? The RMS value is written as 1 by 2 pi integral 0 to 2 pi f of omega t whole square d omega t whole to the power of 1 by 2. This is the calculation of RMS value, students. What is the another name for RMS value? It is a root mean square, that is abbreviation. I am talking about what is the another name for RMS value. This RMS value is also called effective value. Okay, these two formulas you have to use to find the average value and RMS value for a given waveform. Now here I am giving some important waveforms, students. For those waveforms, you directly remember average and RMS values. Not only for power electronics point of view, for other subjects point of view also, these formulas are more useful. Okay. The first one is, for example, if any pulse waveform is given, students, concentrate. In throughout explanation of power electronic circuits, these formulas are more important. Yes, this is the given is pulse waveform. In this pulse waveform, let this is t by 2 and this is t. It is taken as a on time, students. This is on time and this is taken as off time. This is which waveform? Pulse waveform. It is a pulse waveform. If any pulse waveform is given, directly you can apply the formula like this. Let the amplitude of this waveform is A. Then how to find average value? The average value we have to apply like this. You can calculate like this. The average value equal to amplitude into, no need to go for integration, directly you can write amplitude into on time by total time period. Then amplitude into, what are the on time, students? On time by total time period. First I am writing on time by total time period. Okay, that you have to write. This I am writing on time by total time period. No? Yes, instead of time period I am writing as a time period. On time by total time period. Okay, this is formula you have to apply to find the average. Now for the given waveform, the average value equal to, that is amplitude into, what are the on time, students, here for a given waveform? T by 2. What the total time period is t. Then t cancel. Then what the average value you can get? The average value equal to A by 2. That is, if any pulse waveform is given and it is a periodic waveform, observation is important. It is a periodic waveform. If any pulse waveform is given, the average value equal to amplitude by 2. Directly you have to write amplitude by 2. But condition is, it is a periodic waveform. The same waveform is repeating every period. Okay. Then for this waveform, how to calculate the RMS value? Yes, friends. How to calculate RMS value? The RMS value is written as amplitude into square root on time by total time period. No need to go for integration, directly remember like this. Then what is the RMS value? The RMS value equal to amplitude into what are the on time, students? T by 2. How much time it is on in one time period? T by 2. By total time period is T. Then T cancel. Then what the RMS value you can get? This RMS value equal to A by root 2. You can get the RMS value. That is, if any pulse waveform, is it a period? If it is a periodic waveform, then RMS value equal to A by root 2, average value equal to A by 2, students. Okay, this is one waveform. Next, for different waveforms, mostly 5 or 6 waveforms are there. For those waveforms, directly you remember. That is more useful for competitive exams point of view. See the second one. I think all of you well known this waveform, students. Here I am giving it is a triangular waveform. It is a triangular waveform. Like this it is given. You already studied even in network theory also. Let us assume that it is a periodic waveform. It is a periodic waveform. Every period the same waveform will repeat, T to T. Then let us assume that the amplitude of this waveform equal to A. Let the amplitude is A. Then for this waveform, students, one method is you apply integration method and you calculate average and RMS value. But directly I am writing. Then average value equal to, what is the average value of this waveform? The average value of this waveform is, how to write A by 2, amplitude by 2. One of the method to calculate average value for this one is area under the curve. Area under the curve, no? That is of BH by total time period is T. Then we can get A by 2 only. What is the RMS value of this waveform? RMS value equal to A by root 3. Like this you remember. Okay, this is the average value and this is RMS value. Let it may be voltage function or current function, whatever may be the function. It may be voltage or current, students, no problem. You can apply same formula. Okay, it may be voltage or current. See, for example, one more waveform I am drawing. If any waveform is given like this, this is also triangular waveform, but the shape is like this. For this waveform, how to find the average and the RMS value? Let us assume that given amplitude is A, the function is f of t. Let this is t by 2 and this is t. It is also periodic waveform with the assumption of periodic waveform only, students. Then for this case, what is the average value? Then average value of this waveform is A by 4. Then RMS value of this waveform is A by root 6. RMS value is A by root 6. Every observation is important, that you have to concentrate. Okay, this is the average and RMS values. Okay, this is also average and RMS values. Okay, this is third one. One more waveform, the fourth waveform. If the waveform is given like this, I think all of you well known this waveform. It is a full wave rectifier output, full wave diode rectifier output. In the study of rectifiers in power electronics also you can get this waveform. But up to now you remember this one. This also important formula. In most of the subject this type of waveforms will repeat. This is pi and this is 2 pi. Let the amplitude is A. If it is voltage, Vm. If it is a current, it is Im. But I am giving generalized. For this waveform, what is the average value, students? For this type of waveform, the average value equal to 2 Vm by pi. It is amplitude is A, that's why 2A by pi. What is the RMS value? The RMS value equal to, that is Vm by root 2, but here it is the A by root 2, because I am assuming that amplitude is, instead of Vm, I taken A. It may be current waveform or voltage waveform. These formulas are applicable, students. The next one is, fifth one I am writing. This also waveform. This is the half wave rectifier output. This is the full wave rectifier, full wave diode rectifier output, and this is the half wave diode rectifier output. For this type of waveforms, again no need to do the calculations. Directly you remember. This is 2 pi, this is 3 pi, and this is the omega t. Let the amplitude is A, amplitude is A, and it may be voltage function or current function. These formulas are applicable. Then what is the average, students? The average value of this waveform equal to, just like a Vm by pi, but instead of Vm, what I given? A here, A by pi. What are the RMS value, students? The RMS value equal to A by 2. Vm by 2, na, it's A by 2. Okay. Like this, if any waveform is given, this type of shapes, how to find the average and RMS values are very important, that you have to concentrate. For example, if the shape is given like this, yes, friends, okay, this is the square waveform. What this waveform? A square waveform. Let this is t by 2, this is the t, and you take on t axis, this is A and this is minus A. Okay. For this waveform, in one cycle, it is a symmetrical waveform. In symmetrical waveform, for one cycle, it is a positive area equal to negative area, friends. Positive area equal negative area. Then what is the average? Average is equal to 0. What is the RMS? Very, very important. In study of rectifiers, in study of inverters, this waveform will repeat. Just by seeing the waveforms, directly you tell what is the RMS. Again, no need to calculate. For a square waveform, peak value is the RMS value. Amplitude is the RMS value, students. That point to remember. Then what is the peak value here? What is the peak value? A. That's why RMS equal to A. Very, very important. In study of rectifiers, in study of even inverters also, this waveform will repeat. Directly you remember. Again, don't ask. When I ask the question, directly you ready to answer, students. Then for a square waveform, what the RMS value is a peak value. That is, A is the RMS value. Peak value is also A. RMS value is A. But in one cycle, average value equal to 0. In one cycle, the average value equal to 0. Okay, like this, for different waveforms, you have to remember, students. Now, with this knowledge, I have to explain how to calculate conduction losses in a devices. Calculation of conduction losses in a practical switch. Practical switch means that is a practical device. I told already. I am explaining the switch means indirectly I am explaining the device, because every device is used as a switch. Conduction losses occur when the device is in full conduction. When you can calculate the conduction losses? When the device is conducting, then only you can calculate the conduction losses. How to calculate the switching losses, that already given. But here, when the conduction losses are occur, when the device is conducting, then only conduction losses are occur. The current in the device is whatever is required by the circuit, and voltage at its terminal is the voltage drop due to the device itself. That means, if the device is conducting, based on the load, there is some current is flowing. Whenever current is flowing through the device, there is some voltage drop, forward voltage drop. That current into voltage drop, gives the, which one? Conduction losses in a device. These losses are in direct relationship with the duty cycle. What do you mean by duty cycle, students? I am defining the duty cycle here. The duty cycle is written as on time by total time period. That is on time by total time period. On time by period. That is time period. You have to write as a time period. Okay. This on time is also called pulse width. Pulse width. Time period is different, pulse width is different, students. Very important observation. On time is nothing but a pulse width. Pulse width means you have to take only on time. Time period means this time period is nothing but a both on time plus off time. Time period is nothing but a on time plus off. But pulse width is only on time. Therefore, the duty cycle is denoted by any notation. You have to use D, or you can use alpha, or you can use K, or you can use delta. Different authors, they are following the different notations. It is denoted by D or alpha or K or delta. This is T on by T, duty cycle. You can also write T on into F. 1 by T is written as a F. Okay, this is the duty cycle formula. That is, what is the observation here, friends? What I told, the conduction losses are direct relation with the duty cycle. Why it is direct relation with the duty cycle? we know that if on time is increases, if on time is increases, what about the duty cycle increases? If the duty cycle is increases, what are the conduction losses? It is conducting more time, what are the conduction losses also more? The conduction losses also increases. That's why these losses are in direct relationship with the duty cycle. Higher the duty cycle, higher the more on time. Once the on time is more, what are the conduction losses? The conduction losses also more. Now in different cases, how to calculate the conduction losses, that I have to explain. During the conduction, a semiconductor device is modeled as only on state resistance or only cut-in voltage or combination of on-state resistance and cut-in voltage, students. That means we are representing with equivalent model. For example, let us assume that if the diode is conducting, it is modeled, it is replaced by one resistance. For example, let us assume that if the BJT is conducting, it is replaced by one resistance. Or let us assume that diode is conducting, it is replaced by resistance and voltage drop. Like that, if it is modeled in different ways, then whenever current is passing through the device, what is the conduction losses, that I have to explain. That is, if any device is conducting, it is modeled as a only on state resistance, like this also it is modeled, or it is modeled as a only cut-in voltage. Let any current is flowing, it is modeled as a only cut-in voltage or voltage drop, or it may be modeled as a both resistance and cut-in voltage, students. If it is modeled as a both on state resistance and cut-in voltages. If it is modeled as a only on state resistance, how to calculate conduction losses? If it is modeled as a only cut-in voltage, how to calculate conduction losses? If it is modeled as both on state resistance and voltage drop, how to calculate conduction losses, that I have to explain. Listen, students, first I am writing some formulas here. Once you know these formulas, solving of the problems is very easy. Based on this model, already 2 marks question is there in GATE exam. If semiconductor is modeled as only on state resistance, let assume that if any device is conducting, it is modeled as a only on state resistance, then how to calculate the conduction losses? Then if it is given only resistance, students, the average power loss equal to this average conduction losses. Average conduction losses. Then how to write average conduction losses? 1 by 2 pi integral 0 to 2 pi, yes students, I square R on into dt. This average conduction losses or power loss. Then P average is equal to R on is constant, the on state, where R on is the on state resistance. If the device is conducting, it offers some resistance. This is the on state resistance. Okay. Then if it is constant, how to write like this, R on into 1 by 2 pi integral 0 to 2 pi I square dt. I square R on into d omega t you have to write. 1 by 2 pi integral 0 to 2 pi I square R on into d omega t, or you can write 1 by t integral 0 to t I square R on into dt. Once I am writing in terms of omega, in terms of t axis, now I will write like this 1 by t, yes students. How to write like this? This 1 by t integral 0 to t I square R on into dt. Here also I am writing 1 by t, how to write, this is 1 by t, writing like this, R on into, how to write R on equal, R on into, this is conduction losses now, 1 by t integral 0 to t I square dt. Then what this formula indicates, students? What this formula indicates? But it is during which time we are calculating? Only on time, 0 to t on. I am calculating only 0 to t on. Only on time only losses are exist now. That's why I am taking 0 to t on, 0 to t on. Clear? Now what this formula indicates? We know that I RMS equal to, how we can write? 1 by t integral 0 to t I square dt whole to the power of 1 by 2. Correct? This is in terms of t axis. But actually whatever the formulas I given, this I given in terms of omega t axis. This I given omega t axis. But here I am writing t axis. If it is a t axis means instead of 2 pi you have to substitute the t. Okay. Then what this IR? But what is this formula, students? IRMS square equal to 1 by t integral 0 to t I square dt. Square on both sides. That means this indicate the IRMS square. Correct or not? But only limits are here 0 to t, but here 0 to t on. Why I taken 0 to t on? Because we are calculating only during on time. That's for what is the average power loss? The average conduction loss is equal to R on into, this is replaced by IRMS square. That means if any device is conducting, if it is modeled as a only resistance, to calculate the average conduction losses, we have to use RMS current. Don't use the average current. This is the observation. To calculate the average conduction losses, we have to use RMS current, students. Don't use average current. This observation is important. Next. See the one more observation. If semiconductor is modeled as only cut-in voltage, that means if any device is conducting, it is modeled as a only cut-in voltage or voltage drop, where Vd equal to cut-in voltage, or sometimes it is also modeled as a voltage drop. Now in this case you have to calculate the average conduction losses, students. Then how to calculate average conduction losses? The average conduction losses equal to, yes, come on, concentrate, average conduction losses equal to, this P average equal to, same I am writing 1 by T, but the conduction losses are calculating during T on only, 0 to T on, that is Vd into I into dt. But that constant voltage drop or cut-in voltage is constant, na? Then how to write average conduction losses equal to Vd is constant, students, 1 by T integral 0 to T on I dt. Then what this current gives? The average conduction losses equal to Vd into, what this formula, students? It is I average formula. That means to calculate the conduction losses, if it is device is modeled as a only voltage drop, then to calculate the average conduction losses, you multiply that cut-in voltage with the average current. Don't multiply with the RMS current, students. You multiply with only average current. Don't multiply with the RMS current. Okay, this one more observation. Then third observation also you have to see, this is case 3. If semiconductor is modeled as a combination of resistance and cut-in voltage, that is, if any device is modeled as a combination of resistance and voltage drop, okay, this is the R on and this is the voltage drop or cut-in voltage, then how to calculate the conduction losses, students? You already know, if it is modeled as a on-state resistance, then you have to use IRMS, that is IRMS square into R on with respect to resistance. With respect to voltage drop, you have to multiply with the average current, Vd into I average. Okay, if both are given, combinedly you can use whatever the formulas that I given, that combined formulas we have to use. Okay, these observations are important with respect to conduction losses. Now with this knowledge, how the questions you have to solve, that you have to see. Okay, this is one question, students. Once you know whatever the concept I explain, once you know that concept, solving of the problems is very easy. A MOSFET is modeled as on-state resistance of 10 milliohms and voltage drop of 1.5 volts. A current waveform as shown in figure is applied to the MOSFET. Calculate the average conduction losses. Yes, friends. What the data it is given? Given is MOSFET. A MOSFET is modeled as a on-state resistance. On-state resistance of 10 milliohms and voltage drop of or cut-in voltage of 1.5 volts. Okay, this is modeled like this. Now this current is applied to this model. Here combination of resistance and voltage drop, na, wherever the resistance and voltage drop is there, how to calculate average conduction losses, students? That with respect to resistance, I RMS square into R on. With respect to cut-in voltage, VD into I average. With respect to cut-in voltage, VD into I average. Now, to solve this problem, you have to calculate what the RMS and average of given waveform. Okay, for this reason only, starting I given what is the average and RMS value of this two different waveforms. That knowledge is important to solve these models. Can you tell directly what is the RMS of this waveform? It is a periodic waveform, A by root 2. It is a pulse waveform, periodic, A by root 2, that is 10 by root 2 amperes. What is the average of this waveform? Average is equal to A by 2, come on. Okay, this is 10 by 2, this is equal to 5 amperes. Once I know the average and RMS values, students, once I know the average and RMS values, then you have to substitute here. What is the RMS current you calculated, students? 10 by root 2 whole square. I RMS square, no? Square. What is the unstate resistance it is given? 10 milliohms. 10 milliohms. What is the voltage drop or cut-in voltage is given? 1.5. What is the average current? It is a 5 amperes. Then you have to calculate what are the average conduction losses. This is 10 by root 2 whole square, that is 100 by 2 into 10 into 10 power minus 3. Correct? 100 by 2 into 10 into 10 power minus 3. On state resistance is 10 milliohms. 1.5 into what is the average current? 5. Then what is the average conduction losses, students? The average conduction losses equal to, this is 100 by 2, 50. Sorry, you can write directly like this now. I am writing here. Then what is the average conduction losses equal to? This is 10 power minus 3, 3 zeros are cancelled. 1 by 2 is 0.5 is correct. This is 10 by root 2 whole square, 10 milliohms, then 100 into 10, 1000 in 10 power minus 3, 1 by 2, 0.5 volts, 0.5, that is a 0.5, this is 1.5 plus 5, 1.5 plus 5, students, this is how much? 7.5. This is average power loss equal to how many watt? 8 watts, okay, like this. That means, to solve these models of questions, whatever the observations I given, whatever the average and RMS values of waveforms that I given, that is very important observations. Clear. See the one more question. A current waveform as shown in figure is applied to BJT. If BJT is modeled as an unstate resistance of 8 milliohms, then the average conduction losses is, here it is given only resistance, but there is no voltage drop. Then if only resistance is given, what are the formula for? First I am writing the modeling. Given is which one, students? BJT. Then how the BJT is modeled? Only resistance is given. How much resistance it is modeled? 8 milliohms. This is a current. Now if only resistance is given, what are the average conduction losses? The average conduction losses equal to, yes students, I RMS square into R on. Okay, this is the given current waveform. For this given current waveform, what is I RMS? It is a which output, students? Yes, it is a full wave diode rectifier output. Now for full wave diode rectifier output, then what is the RMS value? 2 Im by pi. It is a 2A by pi, but here current is Im. That is 2 Im by pi. That is 2 into 20 by pi. That is 40 by, sorry, it is a, I am talking about the, not which one, students? I am talking about which one? Average. This is average, but I am talking about RMS now. How to calculate RMS, you tell me? How to calculate that RMS value? Here don't calculate average current, you calculate RMS. What are the RMS current, students? Im by root 2. A by root 2, no? Like that it is Im by root 2. What is Im? 20. That is 20 by root 2 amperes. 2 Im by pi is average value, but you don't want average value here because there is no any modeling of cut-in voltage. If the modeling of cut-in voltage is given, then you calculate average also, but I don't want average, that's why I removed that one. I am calculating only RMS value, that is Im by root 2, that is 20 by root 2 amperes. Then what is the average power loss, students? That is 20 by root 2 whole square into how much on-state resistance is given? 8 milliohms. 8 into 10 power minus 3. Now we have to simplify this. 20 into 20, that is 400 by 2. 8 into 10 power minus 3. This is 200 into 8, 1600. 1600 into 10 power minus 3. This is correct. This is 200 into 8, 1600. Then 1.6 watt. What is the average power loss, friends? We get 1.6 watt we can get. Clear? I am calculating IRMS. IRMS equal to IM by root 2, that is 20 by root 2. P average equal to IRMS square into R1. IRMS is 20 by root 2 whole square. What the on-state resistance it is given? 8 milliohms, 20 square, that is 400 by 2, 8 in 10 power minus 3, that is 200, 8, 1600 in 10 power minus 3, 1.6 watt. Very simple. Now. How we are doing these problems? Write down the given modeling. If resistance is given, if voltage drop is given, both are given, how to do the problem, that you know. See the one more question. This is the gate question. I selected the gate question also. It is a gate 2 marks question. Okay, this model, not the same values may be different, but this is the one of the gate model, okay, that you have to take. Maybe this, I think it's the same gate question only, that values, nearer to that values only, you can say. But concept is same only, whatever maybe gate question or ESC question. If the model is asked like this, how it is modeled? If only voltage drop is given, both resistance and voltage drop is given, that you know the concept, apply that. A steady DC current of 100 amperes is flowing through a power module, that is the switch and diode. The power module is having switch and diode, as shown in figure. The VI characteristics of IGBT, given is IGBT, insulated gate bipolar transistor switch, and the diode are shown in figure B and C respectively. The conduction power loss in the power module S, comma D in watts is. You have to calculate S for switch, students, D for diode. You have to find the what is the conduction losses in a power module, whose characteristics also given. Here figure A and figure A and figure B and C is given. Na? This is figure A, sir. And this figure B and C is there. Na? This one, figure B, whose characteristics. And this is figure C. Okay, this point you remember. Here the question is asked, you have to calculate the conduction losses in a device. But this is IGBT, this is diode, students. These two are anti-parallel. If these two devices are anti-parallel, if IGBT is conducting, diode will not conduct. If the diode is conducting, IGBT will not conduct, because in anti-parallel at a time only one device will conduct. But here the question is asked, you have to find the power loss in a module. But in which device you have to calculate, that is not given. No other alternative. See the current direction. The given input current is constant current of 100 amperes. According to given current direction, which device will conduct, friends? With this current direction, diode is conducting. If the diode is conducting, means in that device only conduction losses are exists. The device which is conducting, that device only conduction losses are takes place. Therefore, you have to write according to given current direction, given input current direction, input current direction, which device is conducting, students? Diode is conducting. Diode is conducting. Hence, you have to calculate, yes, friends, conduction losses in a diode. Conduction losses in a diode. Given is constant current of, given is DC current, na? Given this current is DC current. A DC current is, that is a constant current. Given is a constant DC current of 100 amperes. Students, we know that for a constant current, average and RMS values are same. If you take average value, it is 100 amperes only. Sir, if there is a constant current of 100 amperes, sir, what is the average? It is a 100 only. What is the RMS value? 100 ampere constant, RMS value is also 100. Okay, this is I average, this is the IRMS. Now the question is, you have to calculate the power loss. To calculate the power loss, first you have to know the modeling. Which device we are calculating? Diode. You have to know the diode modeling. Sir, why you are not calculating IGBT losses? According to given current direction, diode is conducting, that's why that device only offers the conduction losses. Now, using diode characteristics, to calculate the diode modeling, that's why we calculate the diode characteristics. This is VI characteristics of diode. These are the VI characteristics of diode. From diode VI characteristics, from diode VI characteristics, from diode VI characteristics. How it is modeled, students? The cut-in voltage is 0.7 volts. 0.7 volt is the cut-in voltage. How much resistance? dV by di na? Rate of, that is change of voltage by change of current, that gives the resistance. Dynamic resistance, whose resistance is 0.01 ohm. Sir, why you taking only VI characteristics of diode? Because these are IGBT character, these are diode characteristics now. Because the diode is conducting, that's why diode modeling I am taking. Now this current is allowed. Then what are the average conduction losses? With respect to voltage drop, VD into I average. Yes, friends. With respect to resistance, I RMS square into R on. Correct. Then what is the voltage drop? It is given 0.7 volts. What the average current you calculated, sir? The average current equal to 100 amperes. That is 100 plus. What is the IRMS you calculate? 100. That is 100 square. What is the on-state resistance? It is given 0.01. Then you simplify this one. What are the average conduction losses you can get? This is 0.7 plus into 100. Na? This is 70 plus this 100 into 100 into 0.01. Then what are the average conduction losses, students? This we can get 100 plus 70, 170. It is not a gate model, it is a directly gate question, students. It is a gate question. It is a 2 marks question asked in gate exam. It is not a model, that's directly it's taken the gate question. The average conduction losses equal to 170 watts. Clear? Okay, like this you can calculate the conduction losses in a device. And here you have to remember one note point, students. Throughout in power electronic circuits, mainly in rectifiers case, we have to use this observation. If any waveform is given like this, it is a constant current waveform or constant voltage. Generally, it is a constant current waveform they will give in rectifiers. For this type of current, what are the average values, friends? Average value equal to A. Wherever the constant current is there, average value is 0. Average value is A, not 0, average value. What is the RMS value? RMS value is also A. For a constant current, average and RMS values are equal. Then what is the form factor? The form factor is, how to define form factor, students? The form factor equal to RMS by average. RMS by average, that is A by A, that equal to 1. This is which one? This type of signal is called pure DC. For pure DC, what is the form factor? Form factor is unity. And one more observation you have to remember. If any function is given like this, friends, it may be current function or voltage function, A0 plus A1 sine 2 omega t plus theta 1, or A1 sine omega t, first you have to write A1 sine omega t plus theta 1. But this formula is applicable for different frequency only, not for same frequency. For same frequency, you don't apply this formula. Like this, it may be sine function is given or cosine function is given. For this type of current or voltage equations, average is equal to A0, students. Then how to find the RMS? This you already study even network theory also in AC analysis. This is A0 square plus A1 by root 2 whole square plus A2 by root 2 whole square plus and so on. Clear? Okay, like this you can find the, how to find the RMS value of this one. This A1, A2 are the amplitudes. I am writing RMS now. That's why I am taking A1 by root 2 plus A2 by root 2 whole square plus and so on. For this type of current or voltage equations, how to find the average and RMS value. But one condition is here. These formulas are applicable if multiples of frequency is given. Same frequency is given, don't apply this one. Constant directly indicate the average. RMS is A0 square plus A1 by root 2 whole square plus A2 by root 2 whole square plus A3 by root 2 whole square plus and so on. Okay, this one important topic with respect to semiconductor devices, students. With this, how to calculate the conduction losses in a semiconductor device concept is completed, students. In the next session, one more important topic that I have to discuss with respect to fundamentals, how to draw the ideal characteristics of a semiconductor devices that is directly given in the GATE syllabus. In GATE and ESC exam, so many times that models of questions are repeated. That we will see in the next session. Thank you.